Everybody, this is Larry. This is day 18th of the July Leetcode Day Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. If you came here after the contest, come join me on Discord. We'd love talking about the contest, though. You know, I'm traveling this week, so I didn't do the contest, but that's fine. Anyway, so I'm in LA, so give me some travel tips to LA if you are here. So I'm mostly here to see people. Anyway, a little bit of a ramble there. But okay, so today's problem is reverse nodes in K groups. So okay, so I hate linked list problems. I mean, I'm just really annoyed because it doesn't really come up enough in competitive. So that's why I'm always a little bit awkward about it, because in competitive, usually you never need a linked list because there's always other ways of emulating it. So yeah, anyway, let's kind of actually read this. Given a linked list, reverse the nodes of a linked list K at a time and return its modified list. Okay, so you may not alter the values. Okay, fine. So you have to really change the pointers and not the values. Okay, fine. This is, to be honest, this is not that bad. It is just really, it's mostly really annoying. So, and the follow-up is, can you do in constant extra memory space? I guess this is good practice, but it's really, really an annoying problem. I mean, there's nothing really that complex about it per se. Let me think about how I would do it. How do I do an O of 1? I feel like the weird thing about this particular, or these maybe similar problems, is that there's always that one trick, and it's always a weird trick, but I always forget what it is because it doesn't really come into play except for the once a year I do Leetcode where it comes up. But it does come up on interview sometimes, so maybe I'm just going to accept being bad about it. That said, so maybe for now I'm going to skip the O of 1, and then we can kind of go over it together by looking at the solution or something like that, so I could learn as well. But thinking about the O of n space 1, the easy answer is just do things kind of recursively, or you don't actually have to do recursively. You can just put, because if you have O of n extra space, you just kind of chunk them K at a time and then reverse everything and then set it back up. This is really, this is just a really silly problem. Sorry, there's nothing, I don't think there's anything algorithmically, technically difficult about it. If you do struggle with it, and I think I might, to be honest, just do more practice and get yourself familiar with it. But I don't, everything is implementation, and I think one thing that I recommend for linked lists in general, or in particular, is, you know, have a pen and paper ready so you can kind of trace every pointer after every alterations, because I think that's probably the only thing, like, if you lose track of stuff, right? I mean, because linked list forms are a big exercise in just keeping track of where everything is and what everything is pointing at and so forth. So as long as you're able to kind of, you know, make sure you track everything precisely, that's the difficulty of a problem. And of course, you know, being familiar with your language enough to be precise, but that's, you know, you need that for every problem anyway. So okay, so in linear time, we just let's do it in a dumb way, and then we can kind of think about it. And of course, we will respect, even though we will not do the O of 1 extra memory, we will try to respect as much as we can. We change the node pointers versus just changing the value, which would be even more trivial with respect to just like push everything on the list, reverse it, and then create it again, which is, if I had to do on a contest, I might do it that way and totally be cheating, to be honest. But yeah, so let's what's a clean way of doing it? So in this case, in linked list problems in general, you try to think about edge cases as much as possible, and the reversing is one part of it. And it's easy to kind of over focus on the reversing, but the other one is kind of getting the pointers from the beginning of a chunk and the end of a chunk, and then lining up in a good way, right? Especially when you're manipulating pointers. So yeah, let's think about that. Yeah, so let's just go through it list by list. Let's just have a temporary array of elements, and I can't even spell array. Sorry, my keyboard's a little sticky because I don't know what I was doing with it. No sick jokes, please. But okay, So what I usually do, the first thing I usually do with the head is I have a Sentinel head value. So let's just call it n head for new head is equal to a new node where the next is equal to head. And maybe I just have to -1. It doesn't really matter because I think the default is 0. So that way that we have to reverse the entire list, we still have the entire thingy. So that's one of the things I do it. Yeah, and now that we are doing it with the O of n extra memory way, we can actually be as slap or lazy as we want, to be frank. Yeah. So then let's do it in a dumb way. So let's see. Let's set current is equal to head, right? And then while current is not none. Let's see. Let's make this in a way of array for now, and then we just do append the node, right? And then current is equal to current.next, and in this case, we just have to check that. Okay. If the length of the last list, so this is actually a list of lists, is equal to k, then we just append an empty thing to it. And maybe it's a little bit awkward because I think if k is a multiple of whatever, then we pop off. So I'm a little bit awkward about this, to be like, it is very awkward because it's late. Maybe I need sleep. I actually, my buddy and I drove about 16 hours, something like that, from San Francisco to Los Angeles. We took a lot of fun places along the way, but now I'm really tired. But still, let's get this started. This trip on the road. So if the length of the last element is equal to 0, then we just pop it. This is very awkward, I'm not gonna lie. And then now we know that for each chunk we should reverse it. And actually, let me take a look at how you want to handle. Yeah, okay. So if it's not a multiple of k, then we just leave the stuff at the end. That's what I was looking for. So now all we have to do now is just reverse the list and then have the pointers point at each other. Yeah, I think that's fine. So for let's call it chunk in a way. If the length of chunk is equal to k, then we want to reverse it. Then we reverse the chunk. And then now we just go, okay, new head is equal to, oh, no, we already have new head. New head that next is equal to, can it be 0 elements? No, it should, yep, no, it has at least 1 element. So it's equal to chunk of no, or sub 0, the first of 0 of 0. I think that's okay, yeah. And then now we also do the thing where for chunk in array, and then we just look at adjacent elements, right? This is way awkward, but let's keep an index here just for. I think we have enough, but it is very awkward code, to be honest. And I would recommend, one thing I would say in general, that I am solving these live, so I think I get questions sometimes with respect to all these production level code, right? And to be frank, no, this is not production level code. And these are things that if I'm on an interview, I would communicate this of like, hey, these are things maybe I would modularize in the future, but I want to focus right now on getting it correct. And then we'll talk about how to optimize both in code modularity, making things more modular, modular. So keeping things more modular and cleaning up afterwards, but I'm focusing on getting it correct now. So you kind of, part of both interviewing and in your career is about communication as a software engineer. So setting expectation of what you're doing, and so that they know what you're going for, right? And if they are not happy with your expectation, then they will be like, hey, no, I actually want you to clean this up first. Then you're like, okay, just want to be on the same page, right? So right now, that is a long way of me saying this is a terrible way of doing it. but I'm just getting it correct and getting the flow right, and then we'll use either. I mean, this is what I would say to an interviewer or someone like I now now that I use this, if I have it correct, I'll use this to build test cases to then now test what I will refactor in the future, right? So these are things that if you have experience, you could kind of talk about as well. But that's just my excuse for this code is terrible right now. So I hope that that's okay. Okay, so now for each chunk, we want to look at adjacent elements. So let's just say current, yeah, next is a keyword in, what is that called? Zip, yep. Zip chunk of one to do. And also, another thing is that I know everything is linear, even if it looks a little bit yucky. So, and we'll maybe go over it more in detail, the complexity in a second. But yeah, everything is linear, which is why I'm not thinking about complexity, because I know that linear is going to be good enough. Yeah, so hopefully that makes sense. So x is equal to next, and that's pretty much it for this one. The only thing that we have to do is take the last element, and then we want to set this to the next chunk's first element, right? Of course, we have to do a quick if statement to make sure that yeah, index plus 1 is less than this. I think this should be good enough. I mean, it might not. I feel like I say that very easily, but then I don't. So now we just return this thing, and that's it. That's the key value of the sender values. No matter what happens, you just set to this. Let's run some code or test cases. Actually, just the same except for 3, 2, 1, and then one thing. So this, I know that I see an error already, but let me just finish typing. 3, 1, and why not just do 4 while you're at it? And 5. I mean, why not just bring the whole family for the ride? Okay, so what was the error? I know that. Oh, what did I? Current in zip of chunk. What is current? Current is a list object. Did I miss under? Maybe I pressed in something weird by accident. Oh, whoops. No, okay. I'm mostly okay. I think it's just this, so that I want to create a new list, not and I think this is, no, that one's okay. Okay. So I'm mostly okay, except for the second last list. Why is this? Oh wait, let me check that the other one is actually correct first, because I look beyond. I think this is just a case with respect to this, which is that if this is not true, we have to set it to none, right? Because it still had a thing. So yeah, okay. So that's good. Am I confident about this enough to submit? Give me a second to kind of think about it, because the short answer is no. Am I confident? So let me kind of see what would make me be more confident, right? What kind of test cases do I have? I think actually, to be honest, these test cases are probably vaguely good enough. I mean, maybe we could choose a number so that 5 is not prime, but I think this actually encapsulates a lot of the edge cases, and including this one encapsulates the other one as well. So let's give it a submit. Hopefully it's good, but I feel like cover most cases. Maybe there's a weird one, but okay, so it's accepted. Like I said, this is going to be linear time, linear space. Maybe we'll go over, do they have a solution? Nope. Okay, fine. Maybe we'll go over the I don't know how to solve an O of 1 extra memory, because it doesn't really come up in competitive, to be honest, and that's where a lot of my background is from. But yeah, let's go over the complexity real quick. So this is linear time, because if you trace through every node, we only access it constant number of times. For example, this node, this chunk of code, each node gets appended to an array once. This is just all of 1. And then for each chunk, we reverse it. So that means that for each element, it gets reversed once. So that's all of 1 for each element. And here as well, even though there are 2 for loops, each chunk itself is, it's like one of those things that these 2 for loops together, every element will be accessed all of 1 time. So yeah, so this is also linear. So everything is linear time. And in terms of space, it's really easy to see that there's linear space, because we put everything in an array, and an array will contain one node for each element. So that's basically the idea. linear time, linear space. Um, hmm. Let's let's discover together what the constant space one is, because I it's some like weird things. I always feel like it's some weird thing that I generally don't remember to do. But yeah, oh, okay. So we that was a hard problem. I mean, maybe it's not hard anymore. But what did I click on? Did it not come up? Sorry, friends. Oh, I clicked on database. That's why, by accident. Okay. I can. This is such a regression. I feel like of the old, because I feel like the old problem searching is much faster. I don't know why they do that, but yeah. Okay. So, oh yeah, let's look at. Have I done it before? I have done it before. How did I do it 2 years ago? Hmm. Did I do it this? Which way did I do it? Oh, I actually did it in a. No, this is. I think I did it the clever way last time. Wow, past Larry may be smarter than I am. Dun, dun, dun. Getting old in my age, but oh, I guess that makes sense. You just kind of okay. So yeah, so in case let me bring it back up. So yeah, so this is the constant space one. We basically we basically just this is to reverse a subgroup. Oops, what am I doing? Where you just go from the head to tail, and then you just kind of go. Hmm. Okay. Okay. Yeah. So this is the constant. Past Larry is I don't know, not as tired perhaps, but yeah. Um, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button. Join me on Discord. Hope y'all have a great Sunday. Have a great rest of the week as well. Let me know what you think. Join me on Discord. Stay good, stay calm, stay, good mental health. And I will see you next video.